And I guess we need to go to question 3, huh? All right. If they tell us that minus 10i is a solution, what other solution do we know?
Well, wouldn't 4 also be one just because it says that?
It does, and yes, you're right, 4 is. But the thing about imaginary solutions is they always come in pairs. They never come alone. So if they tell you that minus 10i is a solution, then we also know that plus 10i is a solution. The conjugate. If they say 2 plus I is a solution, then we know 2 minus I is also a solution.
Okay.
So we actually know 3 solutions here. What's one linear factor? What's the 4 translate into?
4xi?
No, it'd be x minus 4.
Okay.
In other words, let's notice what we're doing here. If we come down to something like this, and we say that's equal to 0. Well, we know that the only way that can be equal to 0 is if one of these is equal to 0. So the way we solve it is we say let that equal to 0, which means x equals minus 5, or we let x minus 2 equal 0, which means x equals 2.
Okay.
The difference with what they're doing here is they're giving you the zeros, and we have to work backwards to get the linear factors. So if they tell us that 4 is a 0, then we know that x minus 4 is the linear factor.
All right.
So we know one of the factors is x minus 4, and by the same logic, we know that x plus 10i and x minus 10i are the other 2 linear factors. Now, whenever we have 3 linear factors and we multiply them together, we're going to get a cubic, which is what they have here as a cubic. So all we have to do is multiply these 2 together to figure out what our answer is. Now, to make this a little easier, always multiply the i's together first. In other words, multiply that by that using FOIL. And the reason is that the middle terms disappear. So you don't end up with a trinomial, you end up with a binomial, which makes it easier to multiply by x minus 4. So multiply these 2 together for me. FOIL them or ETM, what is this going to be?
X negative 10i.
Hold on. First thing you're going to do is multiply that by that.
So x times x would be x
squared. Then you're going to multiply that times that.
So negative 10.
Negative 10ix. Then you're going to multiply this times this. Positive 10ix. Means those cancel. And finally, the last term is minus 100i squared. What's I squared equal to?
Negative 100?
No, if I equals the square root of minus 1, what does I squared equal?
The square root of negative 1 squared?
Which is what? What's the square root of negative 1 times the square root of negative 1?
1.
It's negative 1. In other words, if I have the square root of z, and I multiply it by the square root of z, I get z.
Right.
So if I multiply the square root of negative 1 times the square root of negative 1, I get negative 1.
Okay.
Okay? So if we plug in negative 1 for I squared, then this term becomes x squared minus 100 times negative 1, which then becomes x squared plus 100. So when we multiplied these two imaginary terms together, we got x squared plus 100. We eliminated the I, which is good. Now we can proceed to multiply that by the other linear term. You see what I've done here? In other words, I multiplied these two together to get this. Now I have to multiply that by x minus 4. Help me do it.
Okay, so it would be x times x would be x squared.
Hold on. It's x times x squared.
Right, so you'd have x squared for the answer, correct?
Oh, that's x cubed. In other words, when I multiply x times x squared, we're going to add the exponents, and there's an exponent of 1 on that, x. So when I add the exponents, I get that.
Alright. And then...
So this is x cubed is the first term. And how about x times 100?
X, or 100x.
And how about minus 4 times x squared?
Negative 4 squared.
Negative 4x squared. And finally, negative 4 times plus 100.
Negative 400.
So, our answer, if we reorder these in the based on the degree of the polynomial, we get this. And that is our answer. How come that's not letting me type? Oh, there it goes.
Oh.
It wouldn't let me use my number pad. Let's see. Well, I got the wrong one anyway. It's minus 4x squared plus 100x minus 400. Okay, this is similar to the ones we did yesterday. They don't want us to solve it. They just want us to use the rational factor theorem, or what they call the rational root theorem, to come up with possible, then find any actual rational roots. Okay, so they want us to do two things. I guess this will be a two-part question. We'll answer the first part, and then they'll ask us a second part.
Okay.
So, again, what does the rational root theorem say?
It's like all the, Is it factors?
Yeah. The rational root theorem says, now remember, a rational number is any number that can be written as a fraction. It can also be a whole number, but 7/3 is rational. Okay? So any rational roots are going to have this form, P over Q. P are going to be factors of the constant, factors of 4, and Q are going to be factors of 8, the coefficient of the highest degree term. So what are factors of 4?
1 and 4, and then 2 and 2.
And all of these are always plus or minus. So there's possible numerators. Possible denominators are what?
I think,
Factors of 8.
1 and 8, 2 and 4.
That's it. So now what are our possible rational roots? Well, we're going to take all combinations of these. So I'm going to take 1 over 1, 1 over 8, 1 over 2, 1 over 4. So let's list those. Plus or minus 1, plus or minus 1/8. You see what I'm doing here, right?
Yeah.
And plus or minus 1/4. Now let's take the 4 and put it over each of these denominators. So that's plus or minus 4. Well, when I put 4 over 8, I get 1/2, which I already have in my answer, so I don't need to write that again. But then 4 over 2 is plus or minus 2. And 4 over 4 is plus or minus 1, which I also already have. So now I'm going to take the 2 over 1, I already have that. 2 over 8 is the same as 1/4, I already have that. 2 over 2 is 1, I have that. 2 over 4 is 1/2, I already have that. So there is a list of the possible rational factors. And what answer is that? It looks like C. Is that right?
Yeah.
I mean, can't be A or B, so I didn't even check out C, but C looks right. Okay?
Alright.
Now, the actual roots are, or is, because there may only be one. In other words, we don't have to find 3 rational roots to this cubic. Maybe there's 1 rational root and 2 imaginary roots. Or maybe there's 1 rational root and 2 irrational roots. So that's why they say is or are. So we have to determine whether any of the ones we came up with are actual roots.
Okay.
We're going to do it by synthetic division. You know how to do synthetic division?
I think, yeah.
Okay, well, so the first one I'm going to try is going to be the simplest one, plus 1. Now, if we do this synthetic division, or call it synthetic substitution, if it is a root, what will the remainder be? Has to be 0. If I get a remainder other than 0, then 1 is not a solution. That's the 0 root theorem, or the 0 remainder theorem. We got two things going on here. The most important thing is that if 1 is a 0, in other words, the only way we have of telling which of these are actual rational roots is to go through and try them. Okay? and I'm going to try it, and if it's a rational root, then I must get a 0 remainder after I do the synthetic division. So let's see what we get. So do this synthetically. Tell me where everything goes. What goes here?
On the 8.
Okay. What goes here?
8.
What goes here?
34.
Goes here?
34.
Goes here?
Negative 57.
No, we're adding these things.
Oh, I thought we were subtracting them. So that would be 11.
11.
And 11 up there.
50.
And 15.
Since that's not 0, then 1 is not a solution.
Alright.
Let's try the next number that we can try. -1. Okay, again.
So bring the 8 down, and then negative 8, and then 20, or 18, and then negative 18, negative, or positive 41,
Negative,
or negative,
negative 41. We're adding two negative numbers.
and then 41, and then 45.
Again, not 0. Not a solution. If this seems tedious, it is. These problems, you're only going to ever have to do one of them on a test because they take so long that there's no way the teacher can give you more than one.
So bring down the 8, and then 16, 42, and then 84, 61.
Again, not. Aha! There is something worth noticing here. Let me finish this out. 122, 126. There's something called the upper and lower bounds. I don't know if you've had it or not, but it actually is pretty useful when we're trying to solve these things. If when I try a number like 2, I get all the same sign down here. I get positive, 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 positive. Then I know that 2 is an upper bound. It's not a solution, but any solution cannot be bigger than 2. And that'll keep me from having to try plus 4. In other words, the fact that I got all positives as a result of my synthetic division tells me that there cannot be a solution greater than 2. So that's helpful. Still haven't found the solution, but that's what upper bound means. And there's a lower bound theory also. If all the numbers alternate, then you know that it's a lower bound.
So it basically has to be something below positive 2?
Yes. Exactly.
So,
that's all I know at the moment. Okay?
Okay.
And I'm going to, here, I know you know how to do these now, so I'll speed it up a little bit. Notice that they're not all the same signs.
Right.
So, and it's still not 0. So, let's try, I don't need to try positive 4, but I'll try negative 4. Aha, we have some promise here. There is a solution right there.
Alright, so it's -4.
Negative 4 is one rational root. Not only that, but I have the quadratic that's left over after I divide this polynomial by x plus 4. This represents the result. Well, that's 8x squared minus 6x plus 1.
Okay. That's... Do you have to put the x squared in there for, like, will you always do that?
Well, it's always going to be 1 degree lower. In other words, all we're doing is dividing by a linear factor, and if you have a cubic and you divide by a linear factor, your result's going to be a quadratic. So I know right off the get-go that these represent the resultant quadratic, these numbers down here, or the coefficients of my resultant quadratic. So my answer is that for the moment. And we have to investigate whether we can factor this normally or not. We're done using the rational factor theorem. In other words, we found our one key solution, and the reason that's key is because we now are left with a quadratic, and it's quite easy to handle quadratics. There's no problem handling quadratics. Can I factor that?
No.
Well, let's try. We don't really know until we give it a shot. We know that this x, and you understand why x plus 4 is the linear factor, not x minus 4?
Oh, yeah, because you switch them.
Right. In other words, minus 4 was a solution, which means x plus 4 is the linear factor. Now, if I'm going to try to factor this quadratic, what should I try here and here?
You could try negative...
No, it has to multiply to 8x squared. That's the beginning step whenever you're factoring.
4 then?
Well, how about 4x and 2x?
Yeah.
In other words, you got to split the x's up, always. So you're always going to have an x and an x. I actually do have some choices. I could make it 8x and 1x. But it's always a good idea when you're attempting to factor to start with the two closest factors. 4 and 2 are closer together than 8 and 1 are. What's the next step in factoring this? It's always the second step. It's always, everybody forgets it, and that's probably because it's my own personal factoring method. But it's important to try to remember what that second step is. It goes a long way towards solving these factoring problems.
Do you have to do something with the 1?
You have to figure out what the signs are going to be on both of these linear factors. I need to know what these signs are going to be.
Okay, so the first one's going to be negative.
Hold
and the
on.
second one...
In order to know what those signs are going to be, I'm going to look at the sign on the constant. How can I produce a plus 1? In other words, once I'm done, and I multiply this times that, I got to end up with a plus 1. What do the signs have to be?
Positive?
They have to be the same.
Oh, yeah, okay. That could also be...
Only similar signs can produce a positive. If it was plus minus, then this would be a minus. If it was minus plus, this would be a minus. So this is either minus minus or plus plus. And
Okay.
how can we tell? By looking at the middle term. The middle term tells us it has to be minus minus. That's the second step, is to figure out what both signs are going to be. Now the last part is easy. What are factors of 1?
1.
1 and 1. So that's the only choices there. Now the only question is, does that give us this middle term? If it does, we've factored it correctly. If it doesn't, we need to start all over again.
Yeah, it does.
It does, because that is minus 2x, that is minus 4x, and I just only need to check the inside and the outside terms. In other words, I don't need to check to make sure that term's correct or that term is correct. In the process of factoring, that's the way I base the factoring off of, is those two terms. So I'm never worried that I have these wrong. The only one that's always in question is that middle term. Well, this is correct. Now we have our three rational factors. What are they? We know one of them is minus 4. What's the other one? What's the other two?
Plus 4, right?
No, we set each of these equal to 0 and solve.
And 2.
Set 4x minus 1 equal to 0 and solve that.
That would be 4x minus 1.
So solve it. Solve it for x.
You would make the
What's the first step?
4x negative, right?
Give me the first step in solving that for x.
Getting the 4x to the other side, so making it negative.
Or get the 1 to the other side. It's positive right now. I don't want to make it negative.
Alright, then just make the positive one, or make the negative one a positive one.
Well, add 1 to both sides. That's the first step. By adding 1 to both sides of the equation, I get rid of the 1. And that's what I'm trying to do. I'm trying to isolate down to x.
Okay.
What's the second step?
Then don't you divide it?
So x equals 1/4. That's the second answer. X equal 1/4. Now, the third answer is what?
Would you do 2x minus 1?
Equals what?
2x positive 1?
Well, 2x minus 1 equals 0. In other words,
right.
let's review here. When we have three linear factors multiplied together that equal 0, the only way that can happen is if they're each 0, or at least one of them has to be 0. We're going to assume that all three of them can be 0. So I'm going to solve three separate equations. I'm going to solve this equation, I'm going to solve this equation, and I'm going to solve this equation. We've solved the first two. Solve the third one.
Alright, so 1/2.
Good.
1/2.
There's your three solutions.
Alright.
And they're all rational, and notice that every one of them was on our list. It better be.
Yeah.
In other words, we better not have come up with a solution that wasn't on this list.
-4 isn't on there, but...
Well, actually it is. Right there. -4.
Okay.
Plus or minus 4. So let's see. Type an integer or simplified fraction. Use a comma to separate answers as needed. So, -4, comma, 1/4,
Yep.
comma, 1/2. Let's hope that's the last one of those we have to do. Write a polynomial function of least degree with rational coefficients so that p of x is equal to 0 and it has the given roots of x minus equals -5 and x equals 8. So the way we're going to come up with this polynomial is we're going to start by seeing if we know what the linear roots are. What are the linear factors of this polynomial?
Would it be like 1 and negative 5?
Hold on, it's going to be x plus or minus something. A linear factor always needs an x, not an x squared or a square root of x, but an x. And it has to, in other words, they've told us that x equals minus 5 is a solution. So what's the linear factor? Remember, we have to go the other way.
Positive 5?
X plus 5 is the linear factor. If x equal 8 is a solution, then what's the other linear factor?
X minus 8?
Okay, now multiply those two together and you'll have your polynomial.
Okay, so x plus 5. So x times x is x squared.
Okay.
And then x times negative 8 is negative 8x.
Okay.
And then positive 5 times x is 5x. And then 5 times negative 8 is negative 35. Or negative 40.
Negative 40. And then simplify that expression, which means gather like terms.
Okay, so you would have x2 minus 3x plus, or minus 40.
Okay. And if we could factor that, we wouldn't. It says do not factor. That's the answer they want.
Alright.
X squared minus 3x minus 40. X, let's see my keyboard here, squared minus 3x minus 40. Okay, what do we know about imaginary solutions? Do they ever come alone?
Yeah.
No, they don't. They always come in pairs. You'll never find an imaginary solution all by itself. There's always at least two of them. The one we see and its conjugate. So if 1 minus 4i is one solution, another solution is what?
1 plus 4i.
Okay. Now, those are two solutions. They're looking for a quadratic. Well, if we multiply the linear factors together, we'll end up with the quadratic. What's the linear factor? What's one of them?
1 minus 4i or 1 plus 4i?
How about x? Remember, we always got to have x in that thing.
Okay.
So it's x minus the first one and x minus the second one. Remember that if you know your solution, then the factor is always x minus that solution. Okay, so our job is to multiply these two together and see what we get. Well, what's the first thing I need to do in order to multiply them together? Let's remove those inside parentheses. Whenever you have nested parentheses, first thing you want to do is start removing them, beginning from the inside, working out. Oh my goodness. Hold on one moment, Tucker. We only had a half-hour scheduled, and I completely spaced it out. I'm 6 minutes late to my next appointment.
Oh, okay. Yeah, sorry, I forgot to look at the clock.
That's okay. But when you remove these parentheses, you're going to end up with x minus 1 plus 4i times x minus 1 minus 4i. Multiply that trinomial by that trinomial, every term by every term, simplify, and that'll be your answer.
All right, thank you.
Okay? All right, Tucker. Talk to you next time.
Can you click Dave?